Hello students, welcome to 3.4 and 3.5. We're going to talk about the multiplying and dividing of rational numbers. And you'll be happy to know that multiplying and dividing rational numbers is actually a lot easier than adding and subtracting them because you do not need a common denominator. So let's look at the first part here, the product of two integers. Remember, whenever we see the word product, what it really means is multiplication. Okay, so we're going to start with multiplication. First part here is a water cooler can be used to explain the properties of integer multiplications. Assume that we have water flow entering the cooler, and we're thinking of that as positive because the tank is gaining water. And then any water flow that leaves the cooler is thought of as negative because the tank is losing water. So we're going to further suppose that time in the future is thought of as positive, while time in the past is thought of as negative. So let's look at case 1. Suppose that a water cooler is being filled at a rate of 8 liters per minute. So if the cooler is being filled, the tank is being filled, then, just from the wording alone, we can assume that the longer time goes on, the more water is going to be in the cooler. So we're looking at a positive rate of flow, so that's plus 8, and we're also looking at positive time. We're talking at plus 5 minutes. So is there going to be more or less water in the cooler? Now, we don't necessarily have to say how much more water there is in the cooler. We could pretty much answer this right away just by saying more, because there's more water flowing in and time is moving forward. So they're both positives. So I could say, positive times a positive equals a positive. So it's clearly going to be more. Now, if we want to do the actual math here and think about what multiplication actually is multiplication is just repeated addition. So for every minute, we're adding 8 liters. So if you think about it, for 5 minutes, okay, let's just look at minutes here. Okay, there's 1, 2, 3, 4, 5 minutes. And for each minute, how much water is being added? 8, 8, 8, 8, 8. So this is really 8 plus 8 plus 8 plus 8. And when we have repeated addition like that, it's the same as multiplication. So really this is 8 times the 5 minutes is going to be 40 more liters. So our supposition up here that it was going to be more because we're multiplying a positive by a positive is indeed correct. Second case, let's suppose the water cooler is being filled at 8 liters per minute. So again, that's a positive. But now we're talking about 5 minutes before now. 5 minutes before now. So in this case, is there going to be more, or was there more or less? There's going to be, or there was, less. And the reason that we can tell that is because we've got a positive times a negative. We've got positive water and we've got negative time, so it's going to be a negative answer, which means there's going to be less in there. And as we complete the multiplication for this, let's just do the same thing we did before. You don't always have to do this much work. I'm just trying to explain it. We've got negative 1 minute. That was a minute ago. Then negative 2 minutes ago, and so on. Negative 5. So really what we're doing with our water, okay, is 8 liters is flowing out, okay, every minute. Okay? So 8 liters is flowing out every minute. So if we look at this way, it's going to be 8 liters, but our time is going to be negative on this one, which means we got a negative 40 liters. So 5 minutes ago, there was less water in the cooler. How much less? Negative 40. Well, 40 liters less. So the total answer is negative 40. So 5 minutes ago, there was 40 liters less water than there is at the present time. Go on to the next one. Let's suppose a water cooler is being emptied. Okay, so now it's being emptied at a rate of 8 liters per minute. So just picture the bottom of the water cooler and the water's all flowing out. 5 minutes from now, so that's going to be positive time, is there going to be more or less water in the cooler? Now, I think we can just imagine a full water cooler and then water draining out, and then 5 minutes in the future, there has to be less water in there. That's just logical, right? If water's flowing out of the thing. But in reality, the reason this happens is because we've got a negative flow of water and a positive flow of time, and a negative times a positive is going to equal a negative. So let's look at this. We've got minutes 1, 2, 3, 4, 5 minutes. They're all positive because it's going from now into the future. But our water this time, we're actually losing it. So it's negative 8 liters per every minute. Okay? So in this case, it's repeated subtraction, but that's just multiplication by a negative. So if we do our same calculation as we did above, we've got negative 8 liters for every 5 positive minutes is going to be negative 40 liters. So that's how much water is going to flow out of the cooler in the next 5 minutes. Case 4, suppose the water cooler is being emptied, so that means it's going to be negative flow. And then 5 minutes before now, was there more or less water? Okay, again, let's just think of that water cooler, and water is flowing out the bottom. Well, 5 minutes ago, there was going to be more water than there is now, because for the last 5 minutes, it's been emptying out. So I think logically we can say that there was more water in there before we started draining it, right? And the reason for that is we've got a negative times a negative, and a negative times a negative equals a positive. So let's look at our minutes again. Our minutes were negative 1 minute because it was 1 minute ago, negative 2 minutes, negative 3, negative 4, and negative 5 minutes. And our flow of water is negative 8, okay, because we're losing 8 liters of water, okay, every minute that we had in the past. So what that equals out to in the end is we've got both a negative flow and we've got negative time, which means 5 minutes ago, there was actually 40 liters more water. Okay, so when two integers have the same sign, they're product or quotient. So this is division. Whenever you see the word quotient, you need to be thinking division. Whenever you see product, you need to think multiplication. So when two integers have the same sign, their product or quotient is positive. So what does that mean? Okay, that means negative times negative equals a positive. That means negative divided by a negative equals a positive. That means positive times a positive equals a positive. And that means positive divided by a positive also equals a positive. And just the exact opposite is for negatives, right? If they've got different signs, their product or quotient is negative. So a negative times a positive equals a negative. Okay? A negative divided by a positive equals a negative. And these can be switched around. Remember, in multiplication or division, it doesn't really matter which order you go in. That's only for addition and subtraction. So, if you want to write out all the possibilities, then it could be also a positive times a negative is going to equal a negative. And a positive divided by a negative, divided by a negative, is also going to be a negative. So if you want, you can put these, these 8, these 4, and these 4 in a chart. If you feel that'll help you out. Or you can just remember it or memorize it. I think most people just memorize it. So let's find each of the following products. So we're thinking about multiplication here. 7 times negative 6. We've got a positive and we've got a negative, so we know our answer is going to be negative. So 7 times 6 is negative 42. We've got a negative and a negative, so our answer is going to be a positive. So 3 times 11 is 33, so that's going to be a positive 33. Here we've got a negative times a positive, so the answer has to be negative. So that's going to be 8 times 9 is negative 72. And we've got a positive times a positive, which is going to equal a positive. So 4 times 5 equals 20. This is clearly much easier than the work you've been doing with addition and subtraction, where you have to find a common denominator, and you're often using fractions and whatnot. Multiplication is just easier. The only thing you really got to be careful of is when you're multiplying and dividing, you just got to watch the signs. You got to remember your sign rules. All right, now let's look at some more products. In this case, we've got a negative times a positive times a negative. If it's all straight multiplication, you really just have to count the signs. Count the negative signs. Okay? If the negative signs are an odd number, then your answer is going to be negative. If your number of negative signs is an even number, it's going to be a positive. So in this case, we've got 1, 2, 3, 1, 2, 3 negative, so we know our answer is going to be negative right away. We might as well write it. Then let's just do multiplication. 3 times 2 is 6, and then 2 times 4 is 8, so our final answer is going to be 6 times 8 is negative 48. Okay, let's do the same thing here. We've got 1, 2, 3, 4. Okay, so we've got 4, that's an even number, because we've got 4 negative signs, so it's going to be a positive answer. So let's just keep that in mind. We've got 10. Now I'm just going to ignore the signs completely, because I've already taken care of it. I know it's going to be a positive. So 10 times 3 is going to be 30, and then 1 times 2 is going to be 2, and then there's just a 5 on the end. So that's 60 times 5. What's 60 times 5? 0, 300. So I'm not, I'm just ignoring the signs because I figured it would be positive at the end, and I ignored the signs because I figured it would be negative in the end. You could do these step by step. You could go 10 times negative 3 is negative 30, and then negative 30 times negative 1 is positive 30, and then positive 30 times negative 2 is negative 60, and negative 60 times positive 5 is positive 300. You'll get the exact same answer, but I just like to figure out ahead of time, is my answer going to be negative or is my answer going to be positive? Remember, you can only do this if it's multiplication or division. As soon as you get some addition and subtraction in there, then you really have to follow BEDMAS, and you got to be much more careful with your signs. Okay, this continues on here with some more products, so more multiplication. We've got 1, 2, 1, 2 negative signs. So I know my answer is going to be positive because that's an even number. So now I'll just do that. This is going to be 5, and this is going to be 12. Ooh, a little wonky there. 5, and this one's going to be 12. So 5 times 12 equals 60. And I don't worry about the sign because I already figured out here. Okay, now these ones got to be a bit more careful of because we've got a product, or sorry, we've got a power, right? So we've got a negative 2 and a power of 5. But I told you that the same logic applies when you've got powers. So I've got 5 negative, so my answer is going to be negative. So then you just got to know what's negative 2 to the power of 5. Well, if you don't know it off the top of your head, you can just write the repeated multiplication, right? Negative 2, negative 2, negative 2, and one more, negative 2. Put this question over here. 1, 2, 3, 4, 5. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is a negative 32 because I decided early that it had to be negative. Okay, now we've got negative 1 to the 120th power. 120 is a huge power, but it's also an even power, so we know our answer is going to be positive. Okay, now it looks tough, but it's not really tough because we know that 1 to any power is just itself, correct? Okay, I could have 1 to the power of 5, it's 1. I could have 1 to the power of 10, it's still 1. 1 to the power of 1,000 is still 1. So really on this one, all we have to decide is the answer going to be negative or positive? And we said it has to be positive because of the 120 exponent is an even number, so it's just going to be a positive 1. So don't do any more work than you actually have to. 560. Whenever you see a fraction, okay, always remember fractions are division, always. Okay, this is just 560 divided by negative 7. Okay, now you simplify where you can. However, in this case, 7's a prime number, so I can't simplify this anymore. I just basically have to write this as a decimal or keep the fraction the way it is. Generally speaking, when we've got fractions in our question, I want you to have your answer as a fraction as well. So in this case, instead of plugging this in on my calculator and finding out what the decimal is, I'm just going to write this as a mixed number because the numerator is bigger than the denominator. But in order to do that, I have to figure out what 560 divided by negative 7 is. And as it turns out, this one does divide nicely, even though 7 is a prime number. 560 divides negative 7 perfectly. So it would go, 8? It would go 80 times. So this is one negative sign, so we know our answer has to be negative. So I'll just put that down there. And you can trust me, or you can do it on your calculator. 560 divided by 7, okay, or 560 divided by negative 7 is going to be negative, 80? Yeah, I think that's right. If you're ever in doubt, well, you can just do the check in the margin. That's 0, that's 56. Hey, there we go, 560, and that's what I had on the top, so that one checks out. All right, division, 1 negative, 2 negatives. So a negative divided by a negative will be a positive. So now I just got to decide what's 80 divided by 10. That's 8. Next one, I've got 1 negative sign, so the answer is going to be negative. So it's negative. What's 63 divided by 9? 7. And this one, 240 over 120. They're both positive, so the answer is going to be positive. What's 240 divided by 120? It is 2. Start my math there. 8 times 763 and 240, 120 is 2. Yeah, those answers check out. Okay, so that was just sort of a get you going in multiplying and dividing by positive and negative numbers. Now we're going to look more at fractions, because this unit has been mostly about the fraction portion of rational numbers. We're pretty confident that through grade school you were able to multiply whole numbers, even positive and negative whole numbers and integers, but fractions probably not quite as much work. So what we're going to do here is we're going to use whatever process we can to make our lives easier. Multiplying fractions is always tops by tops and bottoms by bottoms, okay? To multiply two rational numbers, use the properties for determining the sign. So we just said, two negatives is a negative, or a positive. One negative, one positive is going to be a negative. Two positives is going to be a positive. That's stuff we talked about in the prior page. We're going to use those properties to predict the sign of the product, and then if the rational numbers are in fraction form, which they are here, okay, we have to multiply two fractions to determine the value of the product. Okay, we multiply the numerators and we multiply the denominators. So tops times tops, bottoms times bottoms. Okay, this is very different from when we were adding and subtracting, where we had to have a common denominator. We do not need a common denominator. Okay, if the rational numbers are in decimal form, just use your calculator. I'm more interested, frankly, in can you use the properties with fractions than I am with decimals. Calculator does the work with the decimals, but you're going to have to think about it when you use fractions. So for number 1 here, it says determine the product. Well, we've got a negative here and a negative here, so two negative signs, it's going to be positive. And it looks like we've got some tough multiplication, because we've got 11 times negative 21, that'll be a big number, and we've got 7 times 44, that'll be a big number. Now we can do that, but when we're multiplying or dividing fractions, our goal is always going to be to reduce wherever possible. And we can reduce by doing canceling between tops and bottoms. You can only cancel top and bottom, and I'll show you how we'll do that down here. What you do is you look at the numbers on the bottom in the denominator, and you look at the numbers in the top, and you decide, is there anything that I can divide out of a top and a bottom to reduce the number? Because just like we could multiply a number by, say, we could multiply a number, let's say a fraction is 1 over 2. Remember in our previous unit, we could multiply both the top and the bottom by the same thing and not change the value. 1 times 1 is 5, or 1 times 5 is 5, 2 times 5 is 10. Well, we know that 1/2 is the same thing as 5 over 10, it just looks differently. We could do the exact same thing with division as well. Okay, so only simplify top and bottom. You can't simplify two of the numbers at the top. It doesn't work. So I'm going to look at the 11 and the 44. I'm completely ignoring the signs because I've already decided my answer is going to be positive. If I look at 11 and 44, I can divide 11 out of both of these. So what happens if I divide 11 by 11? I get 1. Okay. If I divide 44 by 11, okay, that turns into a 4. So now instead of an 11 up top, I've got a 1, and instead of a 44 at the bottom, I've got a 4. I can also do the same thing if I go this way. And by the way, you could do this up and down too. It doesn't have to be across, but this time it happened to work nicely across. Is there a number that divides 7 and negative 21 perfectly? Sure there is. 7. 7 divided by 7 is just going to be 1. So that just cancels out to 1. And negative 21 divided by 7 is just going to be negative 3. Now I'll leave the negative out because I already decided my sign. So I've got a 3 up there. So now I'll just take it below here, and we'll see what we've got left, right? I've got, I believe, a 1 up top on this side and a 1 on the bottom, so that's pretty handy. And then what am I multiplying that by? I mean, technically it's a negative, but you know, we could keep the negatives in if you want, but we already decided our answer is positive. But now we've got a negative 3 up top, and we've got a 4 on the bottom. So now our math is so much easier, because instead of having to multiply these big numbers and figure out the reduction later, we've already done the reducing when the numbers are smaller, and it's a lot easier for us. So now it's just tops times tops and bottoms times bottoms, right? So negative 1 times negative 3 is just 3, okay? And 1 times 4 is just 4. So our answer should be 3/4. And we knew it was positive right off the bat. I just carried the negative signs down here to make sure that we were you know, double checking. But let's have a look and see if we didn't decide to reduce our fractions early. We've got, what do we have here? Negative 11 over 7 times negative 21 over 44. Let's say we didn't decide to make our lives easier, and we just went with the big numbers, tops times tops, bottoms times bottoms. Okay, so negative 21, let's see, what is negative 11 times negative 21? Well, that's going to be a positive, right? So 21 times 11, I'm doing this on my calculator, is 231. Okay, and then on the bottom, I've got 7 times 44 equals 308. Now, that does not look like a very nice number, but as it turns out, if we did this one right over here, it should equal 3 over 4 when we reduce it. Oh my goodness, so what are we dividing out of both of these numbers that's going to make our life easier? Oof, it's going to be a big number. It's going to be a big number. I mean, we can start by dividing by, we can just start by dividing by, I don't know, what goes into 231 nicely? 6? Nope. 7? 33. Okay, so by checking my calculator, I know I can divide both of these by 7, but I'm probably not. I'm not in great shape, so the top divided by 7 is 33. The bottom, 308, divided by 7 is, ooh, wait a minute, that made a mistake there. 308 divided by 7 is 44. Okay, well now we're at a point where I know if I divide 11 out of both of these, I could get to 3 over 4. Okay. So you can do it this way, but once you get to this point right here, it's really tough to figure out what you got to divide out to get down to your final answer. Whereas if you do that simplification earlier up here, working tops and bottoms, dividing out of a top and then dividing the same thing out of a bottom, it makes your life so much easier and you're so much less likely to make a mistake. So let's apply that same logic to B here. We've got mixed numbers, so always convert. So we're going to convert our mixed numbers to improper fractions. That's where the numerator is going to be bigger than the denominator. So when we've got a mixed number, it's times and plus, right? So 3 times 2 is 6, plus 2 is 8, and you always keep the original denominator. And then this one is going to be a negative. Okay, we've got 4 times 1 is 4, plus 3 is 7 over 4. Okay, we've got a negative times a positive, so our answer is going to be negative. Okay, so we know that right away. Well, I might as well just put that negative there. Now let's do the same thing we did before. Can we simplify top to bottom? 8 and 3 can't divide anything out of that. 7, 3 can't divide anything out of that. 7, 4 can't divide anything out of that. But 8 and 4 work nicely. If I divide this by 4, I end up with 2. And if I divide this by 4, I end up with 1. So that's how we cancel those out. So let's rewrite our equation. Instead of having 8 up top, now I've got a 2. I'll get rid of the negative sign for now just because I'm doing this sort of one step at a time. So this side would be positive. 2 over 3, couldn't do anything with the 3. But then on the other side, I've got negative 7, couldn't do anything about the 7. But the 4 is now 1. So now my math's really easy because it's just top by top, bottom by bottom. Okay, I know my answer is going to be negative because we decided that right at the beginning of the question. 2 times negative 7 is negative 14. Okay, and 3 times 1 is 3. So that is an improper fraction. Now we've got to convert it back to a mixed number. So how many times does 3 fit into 14? Okay, 4 times, because 4 times 3 is 12. That's close to 14, right? So we've got negative 4. So if I go 3 times 4, that's 12. How many more do I need to get to 14? I need 2 more over the original denominator. So this number is technically correct, but this is how we want you to write the final answer, as a mixed number. Okay, again, we could have done this with the longer way. We could have done 8 times 7, and we could have done 3 times 4. And they're not as big numbers as what we had in A, but it's still easier to try to simplify top and bottom before you get to your final answer. And you know what? When you do that, when you get down here, if you've done things properly up here, you shouldn't have to reduce this at all. All you have to do is either just keep your answer, if it's like this, or if it's an improper fraction where the numerator is higher than the denominator, then split it into a mixed number, and you know how to do that. It's just so much less likely to make an error on that. All right, example number 2 on Friday, February 5th, 2008. Price of a share in CIBC changed by negative $1.64. So you own a piece of paper that basically says you have 1 share in a company, but the value of that share went down. So that's a negative number. A person owns 35 shares. Well, that would be a positive 35 shares that they own. By how much did those shares change in value that day? So for each share, they've got a positive share, okay? But it's going to be multiplied by a negative value, and that is what they lost that day. So I know our answer is going to be negative. A negative times a positive is a negative. So I've decided right now, whatever my answer is, it's going to be negative. How much did they change in value? It's going to be a negative something, okay? So I've got 35 shares, okay? So if I have 35 shares times the amount I lost for each share, so this is going to be negative 1.64, okay? I know my answer is going to be a negative. It's just a question of what's 35 times 1.64. So 35 times 1.64 is 57.4. So I know it's going to be negative, and I know it's a dollar figure, so I should include the dollar sign too. 57.4. And then because it's dollars, I'm going to put an extra 0 in there. So the shares changed in value by a negative 57.40. So what that means is if you had 35 shares and they were worth a certain amount of money, okay? Well, because of this day in trading, those shares, the total is worth $57.40 less now than it was. So you lost money. All right, for example 3, determine each product. Now we've got decimals. So decimals, let's just plug them in the calculator, but let's decide, okay, always decide, is your answer going to be positive or negative? Well, positive times a negative is going to be a negative. So let's just put the negative sign there, and then we just do the math. Okay, what's 0.8 times 2.4? Just do it on your calculator. So it's going to be negative 1.92. Okay, this one, we've got a negative times a negative. So that's going to be a positive. Okay, that's going to be a positive. So we don't write a negative sign down here. We just got to figure out what's 1.25 times 2.84. And the answer is 3.55. Woo, crazy pen. 3.5. Good grief, pen. 3.55 is our answer, and again, we knew it was going to be positive. So, not worried at all about you with the decimals. You just, as long as you can figure out if your answer should be negative or positive, I'm confident in your ability to plug values into your calculator and get answers. Okay, so I think I'll separate addition and division into 2 separate videos. So that should give you some information for 3.4, and you should be able to complete the assignments on that page of the textbook. Please, as always, email us if you have questions.